Hi and welcome everyone. In this video, I want to go over some examples of the homework. We do have the solution of these homework problems, but let me go ahead and do some of them so you kind of know how this works. So this is, let me show you, this is the homework which is already uploaded. So I picked some problems from here to explain, and the rest you have the solution. You can take a look at the solution and try to do it yourself probably a couple of times. This homework is all for initial value problems. So let's see. The first one, it says find the function y equals to f of x whose second derivative is 12x minus 2 at each point x, y on the graph, and y equals to negative x plus 5 is tangent to the graph at the point corresponding to the x equals to 1. So the second derivative is everywhere. So that's just the second derivative of that function. One thing I don't want you to get confused, if you take the integral of this function, you're not going to get that. So it's maybe that's why I changed the name of that function to h of x. But what does it say at x equals to negative x equals to 1? That's the equation of the tangent line. So what's the meaning of that? That means the slope of this curve equals to the derivative of this function at x equals to 1. And of course, when you have the tangent line, it's like that. So they share the same point. So f of 1 is going to be equal to, let's say, y of 1. That's the meaning of that. From there, we can use those to find the constants. These are the initial values. So let's start. So first of all, this is our second derivative of f of x. And here that function, to not get confused, I called it h of x. So we can find the derivative of that function. So that's just the line. The derivative is going to give you the slope of that line, which is negative 1. And h of 1 is going to be equal to 4 if you substitute 1 by x. And you know that f of 1 and h of 1 are going to have the same values. So this is kind of solving some differential equation the simplest way possible. So we can write y prime of x, the integral of y double prime of x dx equals to the integral of 12x minus 2. Why we do that? Because we want to get y prime. So y prime of x is 6x squared minus 2x. And don't forget, from calculus, you always have to have that constant. So let's call that C1. And we want to know what that constant is. So one thing we know that y prime of x equals to h prime of x at x equals to 1. Y prime of 1, you can just substitute 1 by x here, and that equals to h prime of 1. So because that x equals to 1, that equals to negative 1. We have that. So the only thing left here is just C1. You can simplify a little bit of arithmetic, and C1 is negative 5. So we have y prime of x. Now we want to go ahead and solve for f of x or y of x. So you can say y prime of x dx equals to 6x squared minus 2x minus 5, the integral of that. Therefore, y of x is going to be equal to 2x cubed minus x squared minus 5x plus c2. We always write the constant. So, and also we know again, if this is the curve and that's the tangent line, they have the same value at that point, and that point is 1. So you know that y of x equals to h of x at x equals to 1. And that we have h of 1, which is 4. You substitute 1 by x here, and you are left with just C2. Simplify. That equals to 4 equals to h of 1, and C2 equals to 8. So if you want to write y of x is 2x cubed minus x squared minus 5x plus 8, and that's the same thing as f of x. So That's the function we wanted to find. So just don't be confused, or maybe the notation is not good for this problem. This, you can call it something else, because that doesn't mean you take the integral of this function twice and you're going to get that one. Next problem I decided to do, it says verify that y equals to 1 plus sine x to the power of -1/2 is the solution to this differential equation. So this is just, a differential equation is just an equation. So what we want to do is find y prime, and then you have y, and substitute, and you have to get both sides to equal each other. So this is our y. You want to find y prime, so we're going to use the chain rule. Again, please review your derivatives for the chain rule. So it's -1/2 1 minus x to the power of -1/2 minus 1 is going to give you -3/2 times the derivative of the base, which is negative cosine x. So then what you need on this side is y cubed. Y cubed, that means you take this function and cube it. That's what I did here. So if you do that, exponent to exponent, you multiply, you get 1 minus sine x equals to the power of -3/2. Let's check if these are the same. We have the derivative 2 times that, which is the derivative. Is that equal to question mark that function cubed, which we have it here, we calculate times cosine x. So the 2's cancel, cosine x times 1 minus sine x to the power of -2, and on this side we get the same thing. So the solution is verified. Next one is number 6. It says verify that y equals 3 to the power of x squared plus x e to the power of -x squared plus e to the power of -x squared, the integral going from 0 to x e to the t squared dt is a solution of that differential equation. And when you see this, you should remember from calculus 1, the fundamental theorem of calculus. I'll get to that. So basically, first what we need is the derivative of that function. The derivative, you start term by term. The derivative of e to the power of -x squared, again, is -2x e to the power of -x squared. For this part, you use the product rule, and I put the note for you. The derivative of u is u prime v plus v prime u. So it's the derivative of that function, which is -2x e to the power of -x squared times, that's a function itself, and it's plus the derivative of that function, again, from fundamental of theorem of calculus. We know if you have the derivative of that function is just f of x. So in this case, it's just going to be e to the power of x squared, and times the first function, which is u, which is e to the power of -x squared. So now if you want to check the solution, we are going to substitute. So this is our y prime, or dy dx, we found it. So it was right here, and our function was that originally. It's given, it's right there. So it's going to be, you want to know is just substitute. That is the derivative from here. And one thing maybe I should add here, that when you multiply, you add those two, so you get -x squared minus x squared, and that just e to the power of 0, which is 1. So that's where the 1 came from. So that's the derivative, and plus 2 times xy. So I have my x and times that. So let's see what happens if you distribute. Here you get this, for now stays 2x times that is times the first term, and times you get so should put that here. So 2x times the first term, we're going to get that. 2x times that, and times that is 2x e to the -x squared times that one. And we want to know if that equals to 1. So right here, that's what we want to verify. And after that, it's just canceling. So these two cancel, and these are the same thing. They cancel, and guess what? You're going to be left with 1 equals to 1. So this is a solution for that differential equation. Next one, I tried number 7. What is the slope of the tangent line to the graph of a solution y prime equals to 6 squared of y plus 5x pool that passes through the point -1 and 4. So we know from calculus y prime, or the derivative, is always the slope of the tangent line. So here y prime of xy is given by that function. So at -1 and 4, so y prime of -1 and 4, that's how I did it. You just substitute and you are gonna get 7. So therefore 7 is the slope of the tangent line at this point. So basically we know that y prime is the slope of the tangent line at any point, but we want the slope of the tangent line at this specific point. So you just substitute x and y by its value and you get that. Find the values of m that the function y equals to e to the power of mx is a solution to this one. Same way, you are given y. So what you need to do is to find y, first y prime, and then y double prime, and you have y, and just substitute. See if, how that works. Let's do that. So this is our y. This is our first derivative. The derivative of e to the power of mx is m e to the power of mx. The second derivative is m squared e to the power of mx. Now you have to do is substitute those. So it's 2 times m squared e to the power of mx plus 7 times m e to the power of mx minus 4 times e to the power of mx, and that equals to 0. And if you kind of simplify this, get rid of the parentheses, we know we can factor out e to the power of mx, and that equals to 0. E to the power of mx cannot be equal to 0. So therefore you take that and you put equal to 0, and you can just, this is a simple quadratic equation, solve for m, and that's going to give you the answer. So the other problems, they work very similarly to this. So please watch this couple of times and try the other one. This is not a hard homework assignment. Do it, and then again, you have the complete solution of the homework. Check that. It's a good idea to first do it and then check the solution, see if you got it right or wrong. I think that's it for this video, and I will upload the video for the next lecture very soon. Thank you for watching, and I'll see you in my next video.